Hey, how you doing? All right? Good to see you. Hey, how you doing? Good to see you. Hey, how you doing?
It was something where it was trying to met this guy at my daughter's preschool 3 years ago at Donuts for Dad. And then come find out, he was no Facebook when you start talking to development. I developed something like talking shop. It had stuff next to the next one, but we just find out like a year ago.
You check this out. That's how we're going to record it.
Then he started it up. He didn't start coming several months ago.
Oh, it's got to be
And then he came back and he did it. And the third time he got that problem. So, yeah, that'll work. Yeah.
This is very nice.
Hi there, just checking the audio. Can you just put in the chat window, make sure that you can actually hear us. We'll get started in 1 minute.
Yeah. Yeah, so you do your outside boundaries, kind of like here in the picture. Check on.
Right now, just one product.
Right.
How you been?
I would have to be on my laptop for a lot of time.
Sure. Yeah. I'm not too sure that's going to work.
Can you make me the presenter?
Try.
I did not mean to do that. I also don't know how I managed to do that.
Oh, there you go.
Oh, so Todd's calling pizza place.
All right, we're ready?
So did you see he muted his on the software?
Yeah.
You muted yours? Yeah, I'll just turn my volume down. Okay. So yours.
Okay. Evening, everyone. I'm Molly Hussain. Today, I'm going to start on a topic that is not at all related to cloud optimization and DevOps best practices for startups. Actually, what we're specifically going to talk about is Docker. How many of you guys here have heard about Docker? Good. How many of you guys here have used Docker? Good. How many of you guys here are actually using Docker out in production? Come on, you know where. Good. I knew I would get all of those hands to come down somehow or another. But yeah, if you guys would have said, if somebody would have said yes to that, I would have asked how many of you guys are actually bought Docker as a product or something like that. Doctor's not going to be happy about me saying that. Anyway, I am Ali Hussain. I'm the founder of Heaven. We are a cloud and DevOps solutions company. Most of our focus is on AWS, and we are one of the early Docker partners. So we figured that would be a very interesting topic. We discussed Docker, shared some of the things that we have done with Docker. And yeah, I don't think I like Houston traffic. We're Austin-based. I think that's one of the privileges we get to be established about Houston. Then you guys get to tell us what we're not being to be in the city.
Very nice.
Okay. Quick question. So, how many of you guys, like, I just want to get an idea of what kind of things, or the constitute, what you guys do, how to get a temperature for the room. So, how many of you guys are front-end, HTML, JavaScript, things like that? Okay, cool. And back-end developers? Okay. Does that mean you work in startups?
I work for 2 Fortune 500 firms and 1 startup.
Oh, cool. So you do consulting work,
Bob and Peter work.
Okay. People who are operations. Okay. And people who actually are DevOps, who titles say DevOps or find themselves doing both dev and ops. Okay, and anyone here who is not a coder, who's more from the business side? Simple good, but like taking you light and that expression didn't it? It's complicated. And how many of you guys work for larger companies? Okay. And mid-tier companies and startups? Okay. So most of you guys, a lot of you guys work for startups and pretty even split between developers, operations. Okay, cool. So, you guys all know that cloud computing has turned computing into a utility, and it has broken a lot of the traditional models that we have as far as it offers a traditional model, but it actually modifies it in certain ways. It provides us with very strong APIs. It takes away a lot of the human work out of it, allowing us to actually do what needs to be done. And a lot of the things you get to use extremely instead of actually maintaining your own data center, you can get the guys at Amazon who know how to actually maintain really good data centers, maintain their data centers, and it provides a lot of promises, pay-per-use, dynamic scaling, and as I mentioned, it lets you write things in code and automate your infrastructure. And so we now enter into a lot more possibilities. We start thinking about things that we didn't think about before, in that now our infrastructure is automated. What's next? What can we do? How can we take everything to the next level? How can we make code? How can we improve our delivery pipeline? How can we improve our code pipeline? And I skipped too many tabs. So the one thing that we need to think about is that when we look at cloud, we shouldn't actually be looking at it as the way we used to look at traditional data centers. By the way, how many of you guys are actually using the cloud? Are you guys which cloud? AWS? OpenStack? Okay, so you guys are using. Are you guys using a public cloud or private cloud?
We're a provider.
Okay, cool. And so the thing with cloud is you need to start. If you're going to actually start looking at the cost of things, you find yourself paying a lot of money infrastructure more, you need to become more intelligent in how you're using it. So, what needs to be done when you are on the cloud? Well, for starters, you need to start viewing servers as schedules, not as specs. How many of you guys have heard this analogy before? Okay, quite a decent amount of you. And the basic idea of this is servers, think of them as throwaway objects. They are not important. You do not need an identity attached to them. You should, if anything is wrong with the server, you should throw it away. You should have in your hands a way to recreate a new server to replace the old server. The second thing you should automate is your document. And this ends up coming as a direct result of servers being scheduled, not set. You want the process of creating a new server to be as simple and as painless as possible, as repeatable as possible. You want to, when you're talking about the cloud, you want to automate the creation of the network, the infrastructure. You want to automatically install the software. You want to have alarms in place to detect any errors, and once you detect the errors, you should have actions in place to automatically replace unhealthy servers, so that the system, in its failures, is able to maintain and manage them. You don't try to have things never fail. You try to make sure that a failure is handled correctly. The next step, you should look at renting, not buying, or, well, even worse, not building. So you need to simplify the stuff for yourself. You need so for example, for AWS itself, for any cloud provider that you're using, remember this is a resource that you're paying on an hourly basis. If your developers aren't actually using the infrastructure, the dev stack, just turn it off. If you have lulls in traffic, you should scale your infrastructure down so to save yourself money. So that was the brief intro on the cloud, and now coming more to the Docker side of the conversation. So Docker, what is it? Well, it is a very extremely fast-growing IT technology. It is very amazing how much interest is developed. 2 years ago, it did not exist. Last year, was anybody at DockerCon? So last year they had a huge convention in San Jose. They had the annual Red Hat convention, and people were tweeting about it's really nice of Docker to let Red Hat put their logos up on their convention. That is just how much people were talking about Docker at Red Hat. At LinuxCon, which is the annual Linux convention, I saw some 5 talks on the subject of Docker. Around three of them were by people that actually work for Docker. So a lot of interest. There are a lot of companies of all sizes experimenting with it, looking at it. We know, I personally know of some large enterprise companies that have passed this to look at Docker. There were a lot of 50K plus downloads in the first, in less than 30 days of public introduction. And it really is impacting the way we do a lot of things. So it's definitely attracting the investors. A lot of people are looking at it as what the impact of it will be. But why? So we're going to go over that. We're going to go over some of the basic concepts and terminology in Docker. And we'll do a bit of a hands-on tutorial. And then we'll actually put it into perspective with what you can actually do with Docker. Go over some of the use cases we have used it in what is Docker? Well, it is lightweight virtualization. It is the idea of it takes the Linux concepts for process isolation, LXC containers, and C groups, and takes it to the next level of usability, where you don't actually have to worry and think about these processes anymore. It takes all of these built-in intrinsics, which allow you and that are already there in Linux. There are equivalent things in BSD jails too, which allow you to do CPU isolation, which allow you to do process isolation, memory isolation, network remapping, and it packages them into a nice interface as if you're running a virtual machine. So in the end, you have something which looks like a virtual machine, talks like a virtual machine, but doesn't weigh nearly half as much as a virtual machine. In terms of the kernel side, there is nothing running. It's just one management process on top of a few intrinsics that the kernel already supports. And this lightweight virtualization, and when I say virtualization, I'm using air quotes, because it's not really virtualization. It's not at all virtualization. You don't have, in the traditional sense, you don't have a second kernel running. The fact that it is so lightweight allows you to do a lot of things. Now you don't actually, you can just package everything that you're running inside of your Docker container. You don't have to say, you can, for all practical purposes, run your Docker container in production, and it will work just fine. So, interesting enough, do you guys know who the biggest contributor to C groups has been over the last few years? Anybody know? Microsoft. I think it's been Google.
Just to guess.
Okay. And the reason Google has, because Google themselves internally were using a fairly similar infrastructure in that they weren't using Docker, but Google, Facebook, a lot of these large companies who have a lot of machines, and they can justify putting in that much resource into saving themselves the extra memory, the extra overhead of the kernel. A lot of those companies actually went ahead and have been doing something, building up the kernel, building up the resources so that we can actually run Docker today. So it's an interesting point in that the technology behind Docker, Docker may not be the most stable thing. Actually, Docker has improved a lot over the last few months, but still Docker does have some issues. But the technology behind it is actually really good, really a technology which has been well tested in really large-scale environments. And so, as we're saying, the fact that it is so lightweight, we can actually use it, run it on production. And so, if you're running it on something within a Docker container in production, then you can just transfer your container, run it locally, run it in test QA, you can run it in production. So it makes the idea of actually building something that is portable, works across all of your environments a lot easier.
Yes. Have you ever seen problems that kernel incompatibility, like multiple something runs in one kernel and something doesn't run another kernel?
So right now the requirements of Docker are actually very, very external. I haven't seen any yet, but that might be reason part of the reason why we haven't seen it, because there's not a huge number of kernels which can actually run Docker on. And so the problems that Docker starts to address, I'm sure you've seen all of them. You have an active code pipeline management. You can have inconsistency across the multiple environments. dev and production doesn't match, and people are getting upset. And provisioning resources may take an extremely long time because the VM has to boot up. You have a high number of bills for the number of VMs that you have to support. All of them are not doing anything other than having a machine that is just idling because there's a requirement to have that served on a container, to be serving a particular web page. But the idea behind Docker, or the tagline, is build once, configure once, and run anywhere, as long as you're using it. So, what are the components of it? Well, there is the Docker client, that is the user interface to Docker. It interfaces with the Docker daemon. The Docker daemon sits on the host machine. It answers the request for services. It does all of the management work that is part of Docker. When you try to run a Docker container, it's going to tell the kernel, okay, create a secret for this, allocate this much resources, and an index to keep a repository of Docker containers, of images, and their appropriate permissions. So, the containers. The Docker containers is a set of running processes, the running application. And it can be more than one process, it can be multiple items that are running. It is just the entire environment of what you want to run. In an ideal world would be that each container is running a microservice that other parts of the application end up using. Docker images are the images that Docker uses to launch the container. And a Docker file is a file containing instructions that help automate image creation. So it is a simple sequence of commands that you use to run your Docker container. And the layers are each file system that is stacked in Docker mounts through that. So Docker hands-on. Well, I hope I'm assuming my partner actually expected me to carry good mistakes and never told me that I was supposed to do that. But you can download Docker, you can download, if you're using Linux, you can start running it directly. If you are using Mac, you can search for boot to Docker, and that will install a small Linux VM to run Docker with, and you can similarly install a VM on Windows, but whoever uses that. So, Docker, you can have a bunch of commands. You can use it to you can use it to pull a bunch of preset into public containers in the Docker Hub repo. So there's a container for Red Hat, for Ubuntu, and a lot of
Food right? Food right?
Yeah. Okay. Thank you. And a lot of other parts of Docker. There are a lot of very tiny cores, like the core OS, that have ended coming up, in which really takes out all of the fluff out of the Linux distribution and just have it down to the core. It's going to be less than what you actually end up having. Like a lot of them don't have SSH installed, even though you can't actually think of any Linux system not having SSH installed. But it's a stripped down version of the instances. But the more important thing is that it is something that you can use consistently. So like that, can do.
Can I ask, right before we get started moving into your demo, if the food finally arrived, we're sorry it was supposed to be here an hour ago and the traffic and everything. You guys want to go grab a quick slice of pizza? We've got
Take a 5-minute break.
Yeah, if that's okay. I mean,
that's
are you okay on time?
Yeah, that's
Okay. Okay. I don't know if Greg is hungry or not.
I think there's beer as well. I'm told.
The whiskey afterwards, right? Tequila. I have a feeling this was about to get really interesting, and I'd like to make sure that.
good time to take a break. Yeah. Cool.
I think I'm going to Pizza Brigade too.
Yeah,
There you go.
absolutely. Please do.
I'm feeling that. You guys want pizza?
You do the Bootsy Dog.
Okay. You want me to bring, or are you going to come and grab? Okay. Magic pizza, yes.
Kind of hurt my back.
Did you?
It's alright, but when I sit down, it kind of locks up.
And there should be beverage in there as well. Hey, and when you come back, can you sign in?
Okay,
Yeah.
okay, yeah. I'll sign in before I leave.
Yeah, 14.
That's good, that's 50%, right?
That's 50%. Well, we had 35. We had one decline just a minute ago. Yeah. Okay. But yeah, we're running about 30 to 40% of the RSVPs consistently month over month. So yeah, we're pleased with the way it's really starting to pick up.
This should be software, right?
I don't know the
Training center stuff.
We only know it's included.
We've got offices in Columbus and Dallas, right? They go that half of the way. Maybe that's where the root of improving came from, right?
Bootsy Docker, always fun, always friendly, always funny.
Yeah, always entertaining, right?
Yeah, we've been looking at Docker for a while.
Do you have
about
napkins
6
in
months,
there? I can bring some.
and we're also looking at Chef
What
and
about
Puppet.
napkins?
And we're gonna get those suckers up and running.
Okay, we got awesome.
We got the puppet guy coming next month.
I know, it's
Yeah,
he's a cool guy.
good.
I'll be setting up a POC with him on Thursday.
Oh, really?
So if you want to have,
Did you know him before the meetup? Or?
yeah,
Okay.
I contacted their sales pipeline and
Right.
they sent him over.
Oh, thank you, sir.
Good.
So
I'll test his knowledge first.
Yeah, absolutely. Good. Good meetup for us.
You want a bite?
No,
Take a
I'm
slice?
fine. I'm
Okay.
fine.
You want a drink, a beverage?
No, I'm fine.
What the heck is Bootsy Dog?
Oh no, he's I wish he'd like spring a few questions. So I get a sense that some of these people already know that there's something's done, but
We gotta get like a VM up and start playing with it.
yeah.
Time to be more creative about it.
So I just finding the presentation so far is it kind of making sense.
Why not just follow through it?
Okay, good.
Just want to be asking too many dumb questions when they're just. I'm trying not to, interrupt the speaker as I close things. So I know that the first meeting I was a bit hard on you, so I was like, all right, let me. I won't give him a hard time.
I never went back up front again.
Yeah, I won't give him a hard time. Thank you.
How you doing? Good?
Yeah, very good. I'm quite used to the.
You say you're currently
in winter.
you say you're currently working with
Azure. 75 degrees
and,
it runs.
Yep.
Have you been in?
Where do you work at?
Like 12, 13 weeks now.
Oh, okay.
The last 2 weeks have been really comfortable.
That's the only ones I've been here for, so.
Yeah.
Usually it's like 2 weeks. It's quite
59.
Yeah, I remember like Christmas Day. It's going up
Really?
this year, like last year, it began cold.
Whoever you quite good February, like February. I thought about how to go down. Yeah, that's sorry. Molly, go out with it.
Oh, really? Another round of funding. I just went to New Orleans. And so right now I'm kind of meeting beside or design. One of the things I want to do is make sure it's agnostic as possible. I don't want to get locked into one or the other. No, the core tools in the tools.
The weather's nice. I'm trying to actually. I know that the time we tell the others as well.
Yeah, well, we usually have.
Yeah, we have a great group.
Yeah, I mean, right now Eric was, we were moved to DevOps team together. I think he's the
Yeah.
And then the rest of it's beautiful.
Like, it's just such a fun area. It's gonna be fun to watch.
So y'all do right now?
Yeah.
Right now, like only like maybe do
I know right now is done a lot of internal. I think kind of negotiation. And so really looking for what I've been missing wherever you go, and we're building an hour away. But we're doing the same thing. That's such a fun area. I got to take about a year ago on a project. Just so often I do more and more with it. And then just sort of motivate my colleagues shifted focuses on the market that they're focused on and had nothing to do in that area. So I've been touching this other than myself and my spare time. And it's kind of hard to really make it large scale. We get yeah, we're working. I got to do I got to do one of the services. I love taking that. Put on a nice pressure and I was running those over here. I was doing web roles at all. I it was really freaking easy. You can really easily spin up, spin down.
Just stand up.
Okay, you guys ready to wind up again? You got a thumbs up, thumbs down, don't care.
thumbs up for me.
Ready to go? Ready to get back into it? Okay. Rock and roll.
Okay. So, a lot of the idea behind Docker is to add in an application-like interface. And so a lot of the semantics used with Docker are similar to the semantics used with Git. So it is just like the Git pull command, there is the Docker pull BusyBox or Docker pull Ubuntu. And so what these, the reason these commands happened so quickly for me was because I actually have put these images into my environment already, so there wasn't really anything to download. But otherwise, what would have happened would be that we would have gone to the Docker Hub, which is obviously a play on GitHub, and downloaded the respective image that we had requested. So once you have an image, you can run a command on it. So docker run Ubuntu
There you go.
Hey,
we can run Docker. We can run an echo. We can do ls. We can do commands that all the commands that we use would do. There is bash running on the container, and we can start. We can have these commands running interactively, or for example, how I just showed you, or we can have them running in daemon mode. So we can, for example, if we want to run the Apache we wouldn't want it to be running interactively. We would want it to be running in daemon mode, so that you detach the process and Docker is running in the background. They're similar to the semantics for Git. They also take that the next step further. You have a Docker diff and a Docker commit command to start creating, saving or changes to images, or diffing what has changed. And similarly, you can create. You can use the Docker file to create and create. So we can do. So this is a very simple Docker container. The first part of the Docker file is a from command. This tells you what your base image is supposed to be. The maintainer command is the name of the maintainer that's going to be present on Docker Hub. And anything starting with run is saying, hey, I want to run this Docker container. I want to run this command on Docker container. So all of what these commands are basically doing is loading up, setting up the repos for installing SSH, and exposing expose 22, exposing support on the container, and the final command in a Docker container is the cmd command, and it tells you to launch something in Docker.
Is there a way to do multi-line?
Right?
Is there a way to do multi-line content? Because it looks kind of.
You can use the backslash. So that problem. Yeah, a part of the idea behind the Docker file is that how many of you guys are familiar with Chef and Puppet? And so when you look at config management tools, those things can actually, those are fairly complex configuration files. You have 7, 8 files. You have multiple things. You have multiple services running. You're maintaining multiple packages, multiple repositories, multiple libraries, and there's going to be more than one application running there. So Docker kind of does this on purpose because in Docker they consider that an anti-pattern. In the Docker world, they feel that whatever you do, it needs to be simple, so that you can actually pack that in as a microservice and start using it. So Docker does not at all go with the, hey, this is how I create the perfect state of the server with everything working in sync.
But the purpose of Docker is a container which will work everywhere, and it has fairly complex applications, like more than just create code like Apache.
Yeah.
So that's where you end up with more configuration
duration, and that's where this format is not better enough. Okay, but there's also things like copy commands for copy configuration, copy. But yeah, the idea is sort of to keep everything, instead of making one monolithic large thing, make multiple small things. And on that note, Docker, traditionally there was an issue with that in Docker, and the problem was that Docker is going to, that Docker did not have any mechanism for service discovery, which really was happening in Docker, but late last year, around November or something, they introduced a lot of features dealing with service discovery. Yes, right. STD. STD. Service discovery. So what they did, I think the tools that they introduced, I forget the name, but there was something like Docker Swarm and Docker. The idea being, well, without because it actually is very hard to do this, make everything very small services if you don't know where things are and you end up having to look for these things. So I haven't looked at that too much, but it was something that was interesting. And so you can use the Docker build command to build before. And you can start running a build image. So this Docker, this container starts running at state and has the open exposed for running it. So you can also look at history of what has been run on that container to sort of get an have a background of what is actually happening. So you have to get some kind of an audit so that you can have know what's happening. And again, so these are a small number of commands, but you're probably going to go bigger than that, but you probably don't want to go too much bigger than that for a single purpose. You do want to keep the configuration of each container as simple as possible. And you can create once you are using Docker, you can create a repo and push them onto GitHub onto Docker Hub and create a container, push it onto Docker Hub and deploy from there. So similarly, you also would need to do port forwarding because the Docker container is living inside of something that looks like a virtual machine, and so you need to open up the port for it, and you need to set up port forwarding for it. So Docker provides commands for that. And this is the example of Docker file that we're looking at. So what are the projects that we have done, or what can you use Docker for in this for? So we're going to look at a few of the use cases for that. And there are a large number of use cases. You can use it for simplifying configuration. You can use it for isolating multiple applications that are running on the server, improve developer productivity, create code pipeline management. improves the debugging capabilities because you get a lot better history of what is actually running there. You actually have a Docker dev command to test the container. It shows you which files have exactly been modified. And for rapid deployment, you can running something in Docker is you can kind of get so. If you're running something on the cloud, you have this option of, okay, do I want to build a database image and build everything that I want from the scratch, installing everything using a config management tool, or do I want to do something more interesting? Do I want to bake my image with most of the things installed? Docker kind of lets you have that both ways, and that instead of having to manage these VM images, which are very hard to know what's actually happening, where you end up most of your changes end up going into the smaller thing, the Docker container, so you can start deploying them more quickly. So one setup that we used Docker for was for quick and easy multi-tenancy. And this was for Harman & Bird. They are a solar panel monitoring company. Or they're a solar panel installer who wanted to, who asked us to create a solar panel monitoring application. So, why they came to us in the first place? They had low customer engagement. The only time you actually came and talked to them was, hey, why is my electricity bill so high? I thought I would pay you guys for something. And so they wanted an application to monitor the solar, to have the customer monitor their solar panels. It allowed them to really improve their customer engagement. And the other thing it did was it kept their marketing team in touch with the application team and gave the marketing team more opportunities to upsell their products. Well, another thing that they were doing was that once in this application they could turn off the solar panels remotely. So if somebody, when they lease out solar panels, if somebody's not paying their electric bill, they end up, if somebody's not paying their lease, they end up turning off the solar panels. And then the people were like, well, we might as well pay this bill because it's costing us $200 not to pay this, not to pay this $100. So, which we could have saved that. So, what we basically had was a system that we were expected to be. There were a lot of customers with solar panels installed in their homes, and you were installing this monitoring application on the server side that was receiving the data from all of these. Store the data, create the reports, provide emails to customers, provide monitoring, provide them with the status of their application, and provide the admin controls that we just talked about. So what actually happened was that when that company started looking at that product, looking at that setup, they realized that a lot of our other customers, a lot of our competitors are actually interested in this, and this application is actually a lot more interesting than can actually make themselves some really good money. So what they wanted to do was make that application instead of a single tenant application just for one provider. They could make it a multi-tenant application and start using it with multiple people. So that multiple solar panel installers, solar panel vendors could start set up their own application. So the regular dev solution that you would think about for doing this, okay, well, add the tenant ID in the code and database and everything. You start to need to look it up by tenant ID, start doing that. But the problem was that they had some very quick timelines, and it would have just taken too long to implement this in code. So its code changes when something is working. If something ain't broke, don't touch it. Don't don't try to fix it. It's tedious and it's time consuming, it's error prone, and it's going to cause lots of other issues down the road. So that was one problem that we had with just going in and making a code change. The regular ops solution would be, hey, well, why don't we just give host it for multiple people, give each of those guys their own servers and their own login credentials, do some customization for them, and start using it. So, what's the problems with that? Well, there's the high cost. You're getting a huge bunch of servers. You have to not only pay for the actual physical hardware, you have to pay for the maintenance, and most of the servers aren't really doing it. Just sitting over there, idle. And okay, well, instead of letting them idle, can we just use smaller servers? Well, no. It's theoretically yes, but if we make the server size small enough, the server size affects two factors. It affects the throughput and the latency. We don't actually want to decrease the latency by too much, because if we do, customers will start having a bad experience and it's just going to be working out well. So what was the DevOps solution? Well, start bringing in Docker containers and use that to solve the problem. So each tenant, they got their own Docker container. And what did we get? Well, we got a solution for them in under 2 weeks with no code changes. So all that we had to do was add a shim around the existing application and start running it in that manner. So we were able to run 30 tenants per large AWS instance, and we were able to still maintain the responsiveness that we were expecting. So we got higher speed. We were able to keep the cost low, and most importantly, the code changes were quick. The time to market was reduced. So our takeaway from that is kind of in this whole new DevOps world, well, there are a lot of solutions that you can come up. The dev solution and the ops solution, both of them are actually viable solutions. But with a lot of the new technologies, with a lot of the new things that are coming out, and a lot of the new learnings from the different cultures we have, we can actually take them together and come up with a better DevOps solution that actually takes the best of each of the worlds and brings us to the next level in terms of cost and in terms of technology agility. Yeah.
So on that diagram that you had, did you have a Docker container for the application and Docker container for the database? Or
we put the database in. So the database was Cassandra, and we actually. So at first we were thinking about putting Cassandra in the database, but at the time at which we were using it, there were some issues with running multiple instances of Cassandra in the database and within Docker on the same host, and so we ended up not doing that. But we ended up implementing a schema in Cassandra where we were looking things up by tenant ID, and we did need to make that one change in that those lookups before we actually, fortunately for us, before we just there was a single row and so a single column that we had to look up, and so there wasn't any extra complication we need to add to our schema, but we ended up making it so that each of the containers will do each of the tenants, the tenant ID did become a factor.
So are you saying that a lot of the Docker containers were all using the same database?
They were all
across tenants?
Yeah.
Okay. That wasn't a bottleneck?
Cassandra is a scalable database. So.
Okay.
Yeah.
How did you said you had 30 up to 30 containers on a single large host?
Mm-hmm.
How does that scale? Like, if one container becomes too noisy and it's disrupting the other containers via I/O, via memory, whatever, how do you scale that horizontally so that you release some of that bottleneck?
And so a lot of that is helped by the new a lot of the new things that Docker has in terms of handling multiple in terms of handling and deploying containers in Docker cluster and Docker Swarm. That was not something that we actually did for this client, but basically the architecture, you need to add in a bus to figure out which containers you need to actually deploy this tenant to. So
I can answer that. For example, you can limit container per processor. So you could say these two containers go to processor 1, and these two go to processor 2. In this case, you can limit noisiness of kind of processors. Like you kind of statically allocate containers, Docker or Linux to processors.
Similar to VMware when you're
Yes,
priority.
yes, you kind of like you can use affinity and you can specify it.
And so the other part is that those same Docker container may be going to multiple places, and so that is like there may be multiple containers running on multiple machines which are dealing with the same application with the same tenant, and so that is why as you start to scale, you need to put in a bus to figure out to reroute the traffic correctly.
But overall, like memory becomes an issue, and some auto configuration inside of container. Container doesn't know how much memory actually allocated to it. It sees the whole instance. Like if you see 8 GB, container will think that it has 8 GB.
You can limit that actually. No, you can limit that.
You can limit, but it will not see. You can limit to gigabyte, but if you do like memstat, something like top, it will show you all 8 GB. And when container go over this 1 GB, it will just kind of out of memory.
Yeah. So you can have C groups and Docker allow you to say, do not go with this much CPU utilization for this particular container. Do not go with this one.
There's no CPU utilization. Only affinity.
Right.
There is only affinity among processors, but they don't. I mean, that's where VMware KVM is better in terms because they allow you to do granularity. Use this much I/O, or use this much of VMware or CPU or memory. Docker and Linux container is much more simpler, but it's much more lightweight. So in that kind of trade-off you do.
So another case where we used it, Docker, this was for an application developer workflow using Docker, and this was for Paris.com. And so Auto.com, who is the innovation arm of Paris.com, was our client, and what we basically wanted was a push button deployment of their infrastructure. So a lot of this was simple, the regular AWS. They had an application running on the cloud, and they needed to set up correctly to be distributed. They needed a lot of automation. They needed config management, and so that was the part. But the next thing that they wanted from us was they wanted to have a production environment a local dev environment that matches production. And so that's something that we did for them, and for that we used Docker. So why the developer workflow? Well, Fortunately for us, we are an expensive resource. Unfortunately for our companies, we are an expensive resource. Developer time is actually very valuable. You need to be using it correctly and getting the most out of it. You want your developers to be as productive as possible. By the way, how many of you guys really love going through issues with their deployment process? Anybody?
Well, I don't have anything better to do.
Exactly. So, like, what we really want, just as developers, something that we really do want is for our deployment processes to be simple, for them to be straightforward. We want, when we're working on a project, we actually want to be able to work on that project. We don't want to be, or to have to deal with small niggles and small scripts which keep on giving us issues. And so that's another part of the reason why it's not just the hourly cost of developers, it's more than that in the sanity of the developers, because developers who are maintaining this sanity are a lot more productive and productive development.
Developer sanity is totally,
Non-existent.
yeah. They're all around me all the time. They affect me.
So, another point of it was hiring is difficult and costly, and we want to be able to bring in employees when they're in. We want to plug them in really quickly. And developers, as I was saying, as developers that are less productive, increase the time to market. So, the developer workflow sort of looks like this. You have the developer, they write perfect code without any bugs. It goes to the local test, who signs off on the perfect code without any bugs, who sends it to so they test it locally on the machine and they send it off to push the commit forward. The commit goes forward to QA. Everything works on QA, and you just send it off to production. Except, well, things don't really work. So each of these things is actually a loop, and the least expensive but the most exterior of these loops is between when the developer writes something and the developer tests it out. And as you go to QA, the cost of the loop ends up becoming more expensive. You're going to get the results of your test in in like half an hour, maybe the next day, depending on what your regression pipeline looks like. And if it goes out into production, well, then you're just in trouble. Your manager's going to be talking to you. Why do we have this bug? What are the bugs do we have around this area? We need to do a full code review. Everybody needs to look at your code and make sure that that you don't screw over this company in front of the customers again. So the idea is that we want to catch as many things as early as possible, where there's the least cost. And so when you look at, think about it, 95 to 99% of the time, the developer is just going to be writing something in, testing if it works. And this is especially true for a web application where you make a small change, you need to know what difference it looks like when you look at it. So we know that the developer environment, that's really important because this determines that we want the developer environment, the local test, to be as representative as possible. So what should it be like? First, it needs to be production-like, so that we can actually get something, we know that we're actually testing something, we don't actually send bugs down the pipeline. It needs to be quick. We need to be able to bring up the developer environment. And it needs to be repeatable, so we don't have to worry about the annoying niggles of, hey, this is not right, something was broken in my environment, let me check. Let me destroy this world. Let me bring up a new copy of my Git repo, including the 10 copies that I already have, and I don't really know what's happening anymore. So, when it comes to production life, what were we able to do with Docker? We were able to set it up so that each tier, it runs the same OS and software version. The tiers need to be isolated from the developer's device so that any local changes, any libraries that the developer ends up installing locally don't affect it. The developer might be playing with some other tool and all of a sudden nothing works. How many of you guys have used virtual and in Python? No. Right. And so that goes to, I think Ruby has RVM. Yeah, but it sort of tries to address this problem for a lot of the time. For a lot of things, you need to install different versions of libraries and you need to test with different versions of libraries. And the process is just painful. And so that's one of the reasons. You need to have the tier for your application. You need to separate it out from the actual device because you don't know what's actually happening on your device. And then the last thing is that the tiers need to be separate from each other as a production. You don't want to say, hey, we are going to run in dev run on localhost, and you add in a whole lot of config management changes to make that happen. And all that it does is it reduces the amount of testing that you have in your environment. So an example of this was, hey, they never realized that they needed to run gem install or something until they actually said, hey, there's these two services that were both running on the same server. Now that we need to start scaling up, there's the first step to that is actually putting them on different machines, and then we can look at scaling them up individually. Well, you can't actually do when you do that, things start breaking because this we didn't realize that that you needed to have this dependency in this application over here. And why else does it need to be production-wise? Well, you do want everything to be the same. This is a redacted email, an actual email that I received, and it was like, hey, our URL blah is not working in IE5, but is in Chrome or Firefox. This is only in this environment and not in a dev and prod. We are wondering if there's something in the infra that is causing this behavior. And so all of a sudden, if anything goes wrong, it's like there's a huge witch hunt happening anytime something is broken, and that, hey, what is this over here? Why is something working here? Why is it not working there? It must be the dev squad. It must be the ops squad. Let's have a meeting at the mixed-use drink spot. So yeah, we want you to take the blame for the bug. So you see all of the other reasons why does it need to be quick? Well, okay, what's the build time for you guys? Under 5 minutes. No. It depends. So the default build time when you need to make a build. And so under 5 is very much on the aggressive side. For that matter, you want it to be really in the seconds, because anything more than seconds, you're going to be distracted. You will have to make a context switch. And you're not going to just look at that message string saying, okay, now compiling this file, now compiling this file, now linking this file. There are better things to do than that.
Yeah, you're going to go check email. You're sucked into something else.
You're going to go check email. You're typing to something else. So I actually worked in the processor space. I used to work at ARM, and so in dev time, in the dev world, you can usually get build times and test times of around 15-20 minutes. The basic small smoke that you had to run was 40 minutes. Smoke that you actually needed to run to be able to make a single commit was 3 hours. So, and so any change that you want to make, you're going to run the small smoke, see if everything works. Okay, it worked. Run the big smoke, see if everything works. Not really. You go on, do something else, start making other changes. You have an entirely new world checked out just for this purpose. Later on, you forget that you actually ran the smoke. You go home. The next morning, you come in and hey, what do I want to do today? Okay. Oh, right, I had this check-in to complete. You go to do that check-in. You get a message saying the files have already been changed. So you do an update, and you run a small smoke, and then you run a big smoke.
But there's nothing about Docker. It's like there is very well-defined term is about that you run unit tests to achieve quick results.
Yeah.
And if you just have a small test, that something is really broken. Docker will help with that.
Yeah, no, definitely. And so and what does have that is setting up a really good code pipeline for it, which Docker does help with, but really you can do it without Docker. Having a good setup using Jenkins, and that really does help. But what I'm talking about is at the kinds of issues that you end up facing if you don't actually address these problems. Just in terms of the developer productivity, like the commits that could have gone in the day before, gotten a full set of regressions, doesn't go in. So this is a friend of mine and who works for a Fortune 100 company, and he's like, yeah, it takes 8 minutes to run the basic test, and well, I just go browse the internet for that time and relax. And there are a lot of people that do that.
I know I don't spend 8 minutes. It takes 10 minutes. I spend 20 minutes.
Yeah, you don't do that. Yeah, that's why Facebook has cleared that addictive screen, which just keeps on scrolling down the further you go down that path. And so it is actually a time thing for the developers. You give a small interruption, it will end up translating into an 8-minute interruption, ends up translating into a 20-minute interruption. So it is something that is worth stopping. And so beyond that, we need it to be as repeatable as possible. So the least repeatable is human instructions: install this, install this, install this. And I'm sure a lot of you guys have worked at companies where that was exactly what you had to do on your first day of work. You start installing 10-20 items. And then you start to automate things. You start to script most of it, and hopefully 1 or 2 scripts, 1 or 2 commands run, and things are working perfectly. Well, there's things taking things to the next level. Here is a VM image. Here is a background file that you need to run. This is the one command, and once you run this, everything will be copied from the USB, and you'll be good to go. And even when we're in this territory, when we have things like apt-get installed as a part of the instruction, third-party changes end up affecting. Minor version changes may break some applications. And which is a part of the reason why you want to move more and more towards a container where things are binary, where you're basically distributing binaries. So what we ended up doing was we used Chef, Docker, and Vagrant to create local test environment. And this local test environment was running all of the tiers of the application. So we created a container for each application tier. This way we could model that each of those applications had their own separate dependencies. We were not, if you add a new dependency, you have a way to track that. You use Vagrant to manage the virtual machines for this. The developers in that team were using a Mac, so it was both used for managing the virtual machines and for managing the Docker container. And Chef is what we use for bootstrapping and config management. The reason we used Chef was because they already had Chef recipes, so we just made those Chef recipes work within Docker containers. So basically what we had was inside of the single container, inside of the laptop, we were running VirtualBox VM. And that had all of the various containers. It had applications, the web servers, the database, memcache, and logcache, and the associated Redis for logcache. So we were able to SSH into the container, and we were also able to open the HTTP port. So now all that somebody had to do. So the application code is logged. We shared that volume with the VirtualBox VM, and we synced the VirtualBox VM with the laptop. And so basically, what we, when somebody made the change, saved the file, and then they had a web browser that was already pointed to the URL for the Docker container. And you just refresh your web browser, you saw your change. So it got you the benefits of the local test environment, but at the same time, you were also testing all of the various tiers that they were working separately, that you were not making any mistakes in any of that the production code that's actually going to be running is not having have bugs in it rather than the sandbox local code.
To make sure I understood it correctly, the dev is in their IDE that's running. Is that outside the VM?
The IDE is outside the VM.
And then they make a change in that. There's some sort of watch on the files that will update the Docker image?
Yes, although that watch was kind of not very fancy, it was an arsenic.
Okay.
When you say watch, it does sound a lot cooler than what it really was, but yeah.
I like it. Sounds cool. So just based on whatever tier they're working on, it would immediately update that single tier, and then they could refresh?
No, we did end up refreshing recycling all of this because it just wasn't worth it to try to figure out which tier it was. It was just, hey, let's restart the game.
Okay.
The kinds of things that happened, well, bug duplication works on my machine but not on yours. Everyone's machine was identical. If somebody submitted a bug and completed the bug reproduction instructions, there were huge arguments about, hey, it's not right, right? And that when somebody comes onto the team, you don't have the, okay, this guy is not going to be productive for 2 days. The first day they're just going to be downloading stuff and setting up the environment, and then while they're doing that, the takedown suite does with them.
That's if they've had their password provisions and stuff already, right?
That's right.
And that's, of course, considering that somebody is
true.
provisioned everything.
Yeah.
Another shot across the bow, yeah.
We didn't automate the
Actually,
that
it's
part.
HR. It's HR's problem, because they don't give the ops guys an opportunity to prep anything before a new hire comes on board. Everything's last minute, right? Some guy walks in and goes, hi, I just got started today.
Right.
I don't even have my ID card yet.
So I think what you're getting at is that we need her DevOps or something like that, HR DevOps.
Actually, like when we started working with engineering consultant guys, we realized that a lot of things done by hand. So like some VMware accounts, AD accounts. So and then when we're like, okay, let's automate this guy. But actually, it's all process and like create 3 accounts, like in 3 systems. It's not rocket science, and it should take about 10 minutes. Not a whole day activity. Right. That's right. And like potentially even self-serve.
Would you rather buy Oracle than 50?
I'm just saying.
Oracle can automate it all.
The process is there. The thing is that type of stuff is not right. It takes 10 minutes to actually type 30 seconds to actually type a command. But when you're dealing with that type of stuff, you're now dealing with business processes, right? Where you need to get approvals from so and the manager who put in the request they just said, oh, make this account for the new guy. Okay, well, what's the new guy's name, right? What's his email address? What username should it be? What does he have access to?
Okay, but now the question is, if you need all this information, now it's your responsibility to say, hey guys, send please this email with this information and automate it. And maybe this kind of ideological discussion more like who's responsible for what, but the purpose of DevOps to say, okay, it's everyone's fault. Okay, I will provide more information to you if you tell me what you need. Here's what you tell. Every time you send me an email, provide information. And in this case, you can like, okay, parse it.
And there are definitely things happening along those lines. Like there are HR softwares which make it more of a one-click thing. You add this one person, you click this one button, you send them the offer letter. You click this other button, it means that they accept the offer letter, and you set up an HR sign-up date for them.
Profile. So I'm sorry for bunny trailing or whatever, but I just thought that was kind of an interesting comment there that you spend an inordinate amount of time just prepping the environment for somebody to become productive in, and if we start to kind of extrapolate that a little bit, you can see there's HR softwares, SAP and PeopleSoft and you name it, enterprise applications that provide that, but when it comes down to it, they kind of do a DevOps sort of thing where they say, make this guy's profile like so-and-so, right? And then you go and you adjust based on whether he's a manager or a director or, junior guy, right?
Right.
But, we're talking about, automating this. I woke up the other day and I was hearing my wife was talking about this. She had a new hire come in working for her. It took her like a week to get a laptop or whatever. I'm thinking like a vending machine, that you go in and you just hit the button and the vending machine drops out a laptop and it's already pre-configured. You got everything's already right there.
Yeah, I mean,
pre-install it with the, chef. So
it's definitely something that can, it's definitely a place where you can actually add in a lot of improvements, and there are improvements happening in those processes too. But yeah, all of it is just an iterative process. You can't just go from 0 to
it's not an overnight transition, right?
So I think that's something that we need to think that every single one of these things is going to be a very iterative process, and you want it to be that way because that's the only way you can cross through the institutionalized learning. You can actually get people to make small changes until they actually make a big impact.
Remove the cheese, right?
Yeah.
Or move it just a little bit at a time.
Make the flywheel go faster one small bit at a time. And a part of what we called it ended up addressing a lot of these issues. we can't try it because IT is not up to the dev environment. So who sees the benefits? Well, the management sees the benefits in that the devs and ops are not at each other's throats. How many of you guys have been at meetings where devs are pissed off at the ops because they're not delivering fast enough? And how many of you guys have been in meetings where ops are making fun of devs because the devs live in the wild, wild west where they don't actually care about things working in production? I'm assuming all of you guys have been in at least one set of those meetings, if not both. So teams that work together are surprisingly enough good for business. And so you have happier engineers, you have easier hiring, you made the hiring process easier, but other than that, you actually have created an environment where you've proven yourselves to be dedicated towards engineer happiness, and that more than anything will help you attract top talent. The ops, they feel better because they don't need to worry about multiple environments. There's one standardized dev environment that they need to support. Backend developers, well, they have a homogeneous environment, they have quick feedback. One of the good things about Docker is that everything is checkpointed, there's a commit history, so you can go back to a previous state if you want to. You also have better debugging tools in that you don't know what is happening over here. You can what file is being magically touched, which is causing a particular issue. You can do a diff of the container. Front-end devs, well, they got really quick visual feedback, and they got to avoid doing a lot of installation things that are running a lot quicker for them. So why do we use Docker? Well, it added in the minimum performance in overhead. The company that we were working for, they were a good company. They were providing their developers with nice MacBook Pros. They were not, however, providing the developers with MacBook Pros capable of running 5 virtual machines. Does anybody have a company provide laptop that runs 5 virtual machines? Because if you do, I might be looking for a job.
6 gigabyte by Core 7. SSD.
That's nice.
Stuff replacement is what you need. They weigh like 20 pounds, right?
So I realized I was very spoiled in that I upgraded myself from 128 gigabyte SSD to 256 and 8 gigabyte of RAM, and then I lifted my laptop. Oh my god, this is so much heavier now.
But at the same time, I can tell that I run Linux on the laptop, and that's because I don't use it as virtual kind of thing there, and it helps a lot compared to other people. What's it?
Yeah.
And they have a virtual box and have a virtual box for the repeat all my.
Yeah, that definitely helps, but still, that helps with one VM, but not with 5 more VMs. And then there were the nice tools that Documate gives that help the developers. And so this is something that they didn't do because Docker was not 1.0 at the time, so they were definitely not going to trust their multi-million-dollar website on Docker. They did not run on production, but it is something that they can do. And
good question.
Yeah.
So why are we putting so much emphasis on VirtualBox and local VMs? Why not use AWS or Azure to run your dev environment, spin it up and down as needed?
Expensive access infrastructure. If you keep your packages in your local environment, now you provide some VPN access to AWS environment, or some way to deliver kind of securely transfer data between this environment.
So one thing I would say is that you don't need internet. So
Come on.
If you're not working from your office, there may be a lot of times when you're not doing that. You don't need internet. You don't even have to deal with. I mean, you don't want you're running an IDE over on a remote machine is basically running a graphical interface. I mean, when I've done that, I just closed my eyes and started typing because I could not bear to see the letters pop up.
I used to have that thing, but I don't anymore. I a lot of times remote in to develop, and I don't feel any different than directly on the machine anymore.
Okay.
But they're expensive.
But yeah, it is.
For some amount of people, you have a bunch of dev environments, and if they're more than one VM, it becomes a problem. Because you have choice to have small instances like, I don't know, M1 micro in AWS. And performance is just not good.
Yeah, that's
not
usable.
But when we start, okay, Q3, and now you're talking about like $80 per month to use one VM.
I'd be interested to have that conversation because coming from the outside, I don't fully understand the dev life cycle. I understand that starting at a certain point, and that's part of the reason I want to get more involved in dev now. But why not have a single centralized database that's on a larger server for a group of 5 to 10?
Now you need to maintain it and like, okay, and now database change and like, I mean, we had a couple of environments where people run 5 Apache, one MySQL, several MySQL schemas and database inside. It's not maintainable, it's not reproducible, and it's not like production.
Yeah, I have infrastructure like that. The problem operating into is I have to run the same data infrastructure multiple times because different people want different scale, different people are working different projects, and different people want the database to be refreshed in different cycles. So that's a big maintenance overhead where you want to let the database over be shared across multiple developers.
Something like Chef.
It enables, yes, and because in production you have just one database, that's where Chef or any configuration management starts. When you deploy it in developed environment with multiple databases, it's not production, nowhere close. So you start putting like if I need development, configure this database name. Where you use Chef or Docker, build a MI potentially, you actually deploy it as in production. And definitely AMI, I mean, kind of native to Amazon. But Docker, if you think about it, that's what I think about it. It's very nice packaging system. Cross-platform finally for Linux. No deadline for VM. If you think about that, that's awesome. Because now you package all you no dependency on GLC on this specific system. Everything is packaged within this Docker container. And I mean, it's pretty much they have a free portfolio, so it's just a very good packaging system to deliver. And if you look about CoreOS and really how they kind of start to branch into Rocket. Rocket, yeah. So that CoreOS is essentially OS for Docker as packaging system. You just say, I want this package, go. And from this perspective, it's very nice cross Linux distributed. So as long as you have kernel and Docker, run whatever you want. And this is very powerful. Even like not even lightweight, because LSD is for a long time. You can learn how to do it. Big deal. But the way that it packages everything, deliver for several systems, that's all.
So on the dealing with LXC, it is kind of like LXC for the next 1,000 people in that. Yes, there are a lot of people who are using LXC directly, but what Docker basically does is it democratizes those intrinsic kernels so that it becomes easier for us to use, and that there is one command to do all of these things that would have required a lot more work. So sure, you could write your scripts and build up all of that, but the good thing is you don't have to, and you can get your feet dirty if you need to. But what you were saying about databases, like if you're sharing a database, it still opens up all of the questions on. So there's questions about having multiple databases, then you have a lot of if statements in your Chef code or in whatever code that you have. You have multiple people that can start copying the database, and all of a sudden, if somebody makes a mistake, they upset a lot of other people. Somebody wants to try out what this new schema is going to do. They want to try and change the schema. They don't have a place to experiment. They have to create a new place to experiment. So anytime you have to interact with other people, it's going to tamper your agenda. And as I mentioned, we did not use Docker in production for them. But yes, there's always the potential that next time we do this, we just use Docker and Dockerify all of it.
Can you talk a little bit about the process you would use? So going from traditional bare metal, right, and you've got a blueprint all the way to Docker and the in-between, which is the current, where you've got VMs and you sort of know what the infrastructure looks like, and you can kind of define these environments. Where the other one I thought I heard you describe earlier was sort of a hybrid, where the base node VM was running an instance of Cassandra, and then the other elements were spun up in Docker.
Right.
Can you talk about how you, I guess, educate the user base and the developer base and how you think about those deployments?
Sure. So I guess one thing to think about was what are the services that are the reason it was thought okay to tolerate and to say, yeah, Cassandra is not running within database because we were just running Cassandra as one single service, and we tried actually doing it within Docker, but it didn't work, so we just screwed. Another thing to note about using Docker within a database, don't unless you know what you're doing. The AUFS file system in Docker is going to save everything to RAM, and you'll have to make sure to mount separate volumes for it. So if you're going to be using Docker, embedding your database within the Docker, you need to know what you're doing. But with the idea being most of the applications that we deal with, most of them being stateless, putting them within the Docker container, it just works perfectly. Yeah, so what if this change that we made goes into RAM? We don't actually want to be care about if the application dies anyway. I'm actually not sure if I answered your question.
But I can maybe add a little bit. For example, we thought about using Docker called MySQL upgrade, because at some point you can say, okay, I just mount this data where I keep all my SQL stuff, but binary is just Docker container. So then essentially your sweep is like, okay, I want to upgrade the version like, I don't know, 5.5 patch 3. You just shut down one Docker container, all your data stays on your host file system, and you mount the same file system back to new container. Now it's like just work, because nothing's like changed except binary. And if for some reason it doesn't work, you put it back with no installation, nothing. And that's where, again, this kind of power of Docker is you don't install packages, you don't downgrade packages. Like downgrade path is like always.
Well, I guess I'm sort of thinking at it differently. If you have 100,000 nodes in your environment, you're running this thing in scale. You're not really doing that.
Okay, then you run like, okay, VMware, 100,000 VMware nodes, right? Or what? Or you have physical nodes.
Right, you've got bare metal, and then you virtualize your bare metal. So on top of that, how are you deploying production applications?
So
thinking about that.
So we use LT, but with Docker, like to test with the changes. Like we started with, we create the LT container and test it exactly the same way as it's in VM. So at the moment when we go to production, the only difference between VMware and LT is that it's kind of placed where it's run. But all installation instructions are completely the same. Like the same shepherd recipes, no install, no if else statements, nothing. And next step of the thinking is actually use Docker as packaging system. Just like the artifact which developer delivers is not packaged, not RPM, not data, nothing. It's actual Docker container.
And you're running your own registry or using public registry?
No, right now we kind of thinking about that, but no, we wouldn't do public registry. You would create your own private registry and keep it the same way as you have like CentOS. Same way. You would have releases, versions, everything.
So your release trains and your hotfix process, all that works exactly the same?
I mean, you will need to do some adjustments, but if you think about that, downgrade of Docker container much easier than downgrade of packages. Once you did upgrade in the system, to downgrade it is like, you need to do a lot. You need to know all dependencies, what exactly you had before, it becomes much more complex process.
Yeah, and that's one interesting part about it, that with Docker, it really makes it easy to throw away a container. You create an image, and then when you run the container, make any changes to it. All of those changes will get thrown away unless you commit the container. So when I've worked with Chef and Puppet and Ansible or any config management tool, that ends up being a really great thing in that to actually make sure that your recipe is 100% correct. You have to keep on destroying what you're actually testing your recipe with, or otherwise you end up attempts from previous runs are going to affect the present run.
You have to wash your spatula before you mix the next batch.
Yeah.
Yeah, but overall, we've never seen successful rollback. Like once you do upgrade, you never roll back systems to exactly the same state.
Kill it and then you redeploy it and reapply the.
In worst case, you pretend you have rollback procedure, but really not.
And so Docker does.
Brutal one. But that's what it is. It's like, yeah, we just roll back package. And no, you have like 10,000 dependencies.
So is your Chef application or your Puppet application happening as one of those run lines in the Docker file?
No, we were doing it outside of the container, using and kicking off the Chef from the outside and then taking the container after the run is complete.
Okay, so Chef is operating outside the container, writing config files in the container using the packages.
Yeah, actually, let me remember. No, I am messing up. We were using Chef 0, so yeah, we were actually creating a Chef within the container.
So there's actually in the run line, the Chef.
Yeah. No, it wasn't in the run line. Yeah, it actually was in the run line. Sorry, so this is a long time.
You can I'm having a hard time, because we use Puppet, and I'm having a hard time figuring out where Puppet stops.
But we were using Chef 0. We were using Chef 0, which is the Docker server. That's a pet peeve that I have with both Chef and Puppet, in that both of them are designed to maintain entities that you care about. They actually do break the paradigm for servers, not pets, because the entire mode of operation is for the server to log in, for the client to log in to go into the server, download the latest versions of the config and rerun them, and continue to do that every hour or whatever you set it.
And that model doesn't fix. That's the Docker model.
Yeah, that is not affect the Docker model. And that is why we ended up not using Chef, regular Chef that you think of as Chef. We use Chef 0.
Actually, Chef has concept of containers. Like after Blood Conference, they added support, so they actually allow you inside of Chef have resources which they like start containers, stop containers. Okay. And that's where you can actually also produce some additional configuration and potentially mount the configuration files inside of containers. Okay. And also, if you look into tools to build containers, I just played with Packer, and it supports Docker, so it's supply. And that's where it's really nice, because you define JSON. It's like, okay, this is image, this is my base image, this is provisions I want to run, Puppet, Chef, whatever, and you can just bash if you want, and you just kind of keep it in your say, Packer build this, and it will fit you Docker container. And if you use the same recipes to build AWS, you say Packer build AWS, and it will exactly the same scripts to build AWS based on AWS base. So if you're not ready to go to production with Docker, Packer is a nice way to kind of standardize your build procedure across several platforms. This is the same guy who wrote Vagrant, same wrote Packer.
Just to let you know, we've got 10 minutes left.
And so we created a bunch of scripts to help you with that, and basically we had built from scratch, reset unicorn, run the containers, stop the containers. And one of the things we could not do was put the full cars.com production database on user laptop. So we had to sample the data from that. Yes, not exactly the same as production, but a compromise that we had to make deal with processes. Another thing that happened was they were using SQS, so we actually ended up modifying their application to use RabbitMQ instead of SQS. And the other problem is when we did this, there was absolutely no support in Docker for service discovery, and so we ended up putting rules in XCHost. Another thing that was happening was that their website had peculiarities with how the URL was read, in that you actually did have to have dot because it was modifying the URL. So we had to actually modify XCHost for them. And what we get for all of this automation? Well, we got things. We got help people make changes and not have to deal with issues as much. We improved the continuity and made it easy to people and reduce the amount of conflict. Increased the iteration, improved the iteration process, and made it easier to hire talented, interesting people. So we just don't have time for this actually. So Pinchip is another person that one of our clients that was using Docker. If you guys were at AWS reInvent, they talked about it there. So watch the AWS reInvent second day keynote and just find out what they do use Docker for. And with that, any questions, everyone? I know you had some very lively discussions, but yeah.
Yep. You mentioned that in that first app where you're trying to get issues running like Cassandra inside of Docker.
Yeah.
So that kind of implies that an application needs to be somewhat aware that it's running inside Docker, or something like that.
We did not have issues running Cassandra within Docker. We had issues running more than one Cassandra container within the same local machine of Docker.
Okay.
So,
well, I guess that's kind of
but
sort of. I guess the idea is, is there some, if that particular application has problems with multiple instances of itself running within a Docker, what does that say towards other applications, right? Are you going to start running into issues where, let's say Apache or whatever? I mean,
do you know the nature of the problem? This is a really weird problem because
it's a very exceptional problem, and it should not have happened. And mind you, this was on very early version of Docker. This was Docker beginning of 2014. So we haven't checked recently, but the problem may have just been resolved because it is definitely a Docker bug in that if you their entire point is that they are isolating the processes. The Cassandra process should have been completely isolated from any other Cassandra process running in the machine. No matter what the application is doing, that is something that they should have been doing. So,
it's a growing pain.
Yeah, it's a growing pain. I'm not sure if the problem is already there, but it really is something that was on Docker. For the most part, you want to see this issue.
And just separate topic on as far as like the repeatability type stuff. When you show that one example of a Docker running inside the virtual box or VM or something, from my perspective, that kind of just looks like. I don't know. We probably don't have time to get all of these details here, but it kind of just looks to me like if that Docker container is now just this big binary blob that you're shipping around, and you're kind of saying repeatability, but you're really just taking all this junk and throwing it into one big opaque blob, and then you're saying, oh look, we can move this blob around and do wherever we want and call that repeatability. That's not, to me, that's not repeatability.
So I guess and I've realized they're probably gone by now because they only heard half the conversation. So the question was, how is just making everything into binary the same as repeatability? And I guess the thing is that making things into binary is actually making things into binary is actually a very positive thing as long as you can manage that correctly. Like the real problem is not in that you have a binary. The real problem is being able to manage things effectively. So using Docker files, that helps you in any change that you need to make. It needs to go into the Docker file. That will help you in managing the binary correctly, and in that there is a version control system checked in that records what all the changes over here are. The Docker has their ideal use case in which your code pipeline basically means I made some code changes. I've had to add in some package to do that. Let me change my Docker file right now. When you deploy it, you will build a new container with a new Docker file and use that to run your code. So doing that helps in repeatability if you're doing it correctly. If you're not, then yeah, you can run into the same problem. The other thing is that problems that you're talking about are very real problems, and that is about the reason why Docker, the default scenario for that is provides a lot of tools by default that helps you address some of the more glaring issues. So that's why they have the Docker history command, so they can see, okay, these are all the commands that were run on the Docker container. You have Docker diff, so that you can see what are the files that have been touched between on this container so far, and you can use that to figure out what information would have without Docker. So it's a nice packaging on things that we done without Docker. Definitely agree on that. But it is a nice, very nice, useful packaging. So it creates all of these layers which help you manage those binaries more effectively. And in some cases, having binaries is exactly what you want. Like you want so I saw this presentation from this company called Apsoma, who uses Docker for bioinformatics work, and they basically have a batch processing engine. Their code is written in Docker containers. They have a bunch of workers, and the workers, and when you extend a command to that engine, you can include, hey, this is the Docker container I want to run on. So each of your batch commands may be running a different application altogether. It's just that once you run that application once, you got the image downloaded, you can run it. The other thing is you're not a Docker container tends towards not encouraging changes in the Docker container. So you'll have any change that you make is not committed until you go in there, make the change, and then push the change. Yeah.
Thank you.
Thank you. Thank you. All right.
There is 5 people still on. Let me stop recording. I don't know. They're dropping now.
And thank you for having me.
Yeah, no, it's very nice of you to stop and share your experience and making the trip.
You're welcome.